In this video, we are going to talk through a review for our quiz coming up on inverses. So what I want you guys to do is work this problem, pause the video, put your answer in, and then I will talk to you about how to solve it. Okay, try to remember that this number is the domain number of our original function f, and this number is the range number. So when we go to our inverse, remember the inverse takes that range value and turns it back into the domain value. The domain of the inverse is the range of the original, and the range of the inverse is the domain of the original. So this one, when I put it back in there, even without seeing the function, I know the answer is going to be 2, because it's going to take this range value and turn it back into the domain value that we had to start with. Okay, do the same thing on this one. Pause your computer, answer the question, and then we'll talk about the answer. Okay, so remember that when you look at the inverse, it is a reflection across the line y equals x. So every range value, every y value becomes an x value or a domain value, and every domain value becomes a y value or a range value. So you basically just flip-flop the x and the y, do not change the sign, just flip-flop the order of the x and the y. Okay, pause the video and answer these 2 questions. All right, so what is f of f inverse of x? Okay, so remember, this is my original function and this is my inverse. And here I have it the opposite way, the inverse and then the original. In both of these cases, if I compose the original and the inverse, no matter which order I do it, the answer is going to be x. It puts me back to where I started because the function and its inverse undo one another. Okay, let's see if you guys can find this inverse. Find it and then type it in using the equation writer. Okay, remember the steps. We're going to replace f of x with y. And we swap x and y. Okay, now we're going to solve for y. So add 18 to both sides. And then divide both sides by 11 to get y by itself. And then go back and replace y with f inverse x. All right, you could also have written this one as 1 over 11x plus 18 over 11, putting that as 2 separate terms to emphasize that in my line, here is the y-intercept and here is the slope. Or you can leave it like this as one fraction. Either way is fine. Okay, same directions. See if you can do this one that has a fraction slope. Okay, so I'm going to replace f of x with y. Then I'm going to swap the x and the y values. Okay, now let's solve for y. So I'm going to subtract 8 from both sides. All right, now I'm going to do this in 2 separate steps so you guys can see it. First, I'm going to multiply both sides by the denominator. So I'm going to distribute that 5. And on this side, the 5s are going to cancel out. Divided by 5 and multiply by 5 cancel each other out. And then I'm going to divide by 3 like we did before. Okay, so again, when I replace y with f inverse x, I have 2 choices. I can write it like this with 1, 3 in the denominator, or I can write it like this, separating out the slope and the y-intercept. Either one of those answers is acceptable. All right, so let's see if you guys can figure out which graph is the correct one. All right, so remember we said that the x and the y values flip-flop and that they reflect on this line y equals x. Okay, so I automatically know this one is not correct because here's my reflection line right here, and my red and my blue are on the same side, so it cannot be a reflection. That's not the answer. Okay, let's come over here. So this one maybe, let's check some of the points. So do you remember that we said on the mirror line, on y equals x, any point where it crosses, the two functions should meet. And so look, this one crosses here, but this one crosses down here. So they're not meeting on the line y equals x. So that one can't be right. Okay, let's try this one. This one looks good. They're meeting on the line y equals x here. Let's test a couple points. So I see the point 4, 3 right here on the blue one. So if 4, 3 is on the blue one, 3, 4 should be on the red one. Let's check. 3, 4. Okay, that looks good. All right, let's check our x-intercept here. Our x-intercept is a little bit less than 2 on the red one, which means on the blue one, the y-intercept should be a little bit less than 2. So this one turns out to be the correct answer. The function and its inverse are graphed correctly on C. Okay, do you remember what I said? A couple times I've said this. The equation of the purple dotted line, that mirror line, is what? Well, it's the line y equals x. All right, that's really important to know that our function and its inverse are reflections of each other across the line y equals x. Okay, so let's do some trig ones. Let's do some trig inverses. All right, look at this. The way this is defined, that tells me that I want my answer to be in radians. So when I get ready to figure this out, I know I'm going to want two angle answers, and both of them are going to be in radians. All right, so look at your unit circle stuff. See if you can figure out which angle has a sine of square root of 3 over 2. Don't worry about the negative right now. Just focus on this. What angle has a sine of square root of 3 over 2? Then, once you figure out what your reference angle is, figure out which two quadrants sine is positive and type those in radians. Make sure you use radian answers. All right, let's see how you did. So here's the triangle that I'm going to look at because I can see the square root of 3 and the 2. So for sine, the ratio is opposite over hypotenuse. So the square root of 3 is opposite the angle that I want to be looking at. So I'm looking at a 60-degree angle. Okay, I'll make a note of that over here. That's my reference angle, 60 degrees. Now, which two quadrants is sine negative? Okay, so let's look at our diagram. I can see that sine is positive here in the first and here in the second, which means that it must be negative here in the third and here in the fourth. Okay, so let's see if we can figure out our 60-degree angle in the third quadrant and the fourth quadrant in radians. Now remember, I told you guys there's two different ways to do this. First way, if you want to do it in degrees and then change it into radians, that's okay. So let's see what would have a reference angle of 60 degrees down here in the third quadrant. So to get into the third quadrant, I've gone past 180. I've gone 60 degrees more. 60 degrees past 180 is going to be 240 degrees. All right, and then if I continue on over here, I didn't make it to 360. Remember, my reference angle right here is going to be 60 degrees as well. So 60 degrees away from 360 is 300. Okay, now let's change both of those into radians by multiplying by pi over 180. Okay, so for time's sake, I'm going to do this quickly. 60 goes into 240 4 times, and 60 goes into 180 3 times. Okay, so 240 matches with 4 pi over 3. And now let's do 300. 60 goes into 300 5 times. 60 goes into 180 3 times. So there's my fourth quadrant answer. If you wanted to do it straight in radians, you need to remember that 60 degrees matches with a radian angle of pi over 3. In the third quadrant, remember that the numerator is 1 more than the denominator. And in the fourth quadrant, remember that you have to do denominator times 2 minus 1. So either way, you end up with these two radian angles for your answer. All right, let's do this one. So first of all, I noticed that I've changed from radians to degrees. So we're going to think in degrees this time. See if you can figure out which angle has a cosine of square root of 2 over 2. And then see if you can figure out which two quadrants cosine is positive. And then write your two angles in degrees as your answer. Okay, so here's my triangle. Hopefully you figured out that it was this 45, 45, 90 triangle. It's a little bit tricky on this one because it has been rationalized. This one was 1 over the square root of 2, and then remember we couldn't leave it like that, so we had to rationalize it. That's how it came to have the square root of 2 in the numerator. So you might need to quote unquote unrationalize it so you can figure out what it is. So my reference angle is 45 degrees. And now I need to know which two quadrants cosine is positive in. Well, cosine is positive here in the first, so 45 degrees will be my first quadrant answer. Cosine is also positive here in the fourth. So if I go around the unit circle and I stop right here, 45 degrees away from 360, 360 minus 45, 315 degrees. So this time the question asked me to answer in degrees, so I've given 2-degree measures. I do not need to change this one into radians. Okay, last one. Let's see how you guys can do with this one. Notice that it's written a little bit differently. Instead of doing cotangent inverse using that -1 notation, I decided to use arc cotangent on this one. And again, I'm going to ask for a degree answer. You do not have to change this one into radians. Okay, so think through that same series of steps. Which triangle am I looking at? Which angle am I looking at for my reference angle? Which two quadrants is cotangent positive, and then figure out what your two angle answers are. Okay, so this one is my 30, 60, 90 triangle, and cotangent. Cotangent is adjacent over opposite. I did not choose to rationalize this one. I've got adjacent over opposite. Okay, so look over here. Which angle has an adjacent side of 1 and an opposite side of square root of 3? Well, that's going to be 60. So similarly to what we did before, my reference angle here is going to be 60. This time I don't have to change it into radians, however. Cotangent is positive in the first and the third. So 60 degrees is my first quadrant answer. We're good with that. So now let's figure out the third quadrant answer. To move my reference angle of 60 degrees into the third quadrant, I'm going to go around past 180, 60 degrees more. So 180 plus 60 degrees more, 240 degrees. So my two answers here are going to be 60 degrees and 240 degrees.